In this video, we discuss sign diagrams, which indicate when mathematical expressions are positive or negative. Solution sets, a formal way of describing collections of real numbers that satisfy a specific criterion or criteria, often associated with sign diagrams. And interval notation, which is a succinct way of describing lots and lots of real numbers that fill up certain parts of the real line. We begin by discussing the notions of positive and negative when applied to real numbers. The real line splits naturally into two halves, divided by the number 0, which we think of as exactly in the middle. We often denote positive with a big plus sign and negative with a big minus sign. Now 0 is neither positive nor negative. It's just stuck there in the middle, separating the positive from the negative real numbers. Now, in an earlier video, I discussed interpreting a product AB as an area of a rectangle, where one of the side lengths is A and the other side length is B. Now, notice when I labelled the edges of this rectangle, I was careful not to assign any sense of direction. If you include in your mathematics an idea of direction, then you get this notion of positive and negative. Okay? And when you do that, then areas can also have a positive or a negative aspect. Positive and negative orientations of numbers occur quite naturally in everyday life. For example, if you drive along a straight road, you can move forwards or you can move backwards. And if you think of moving forwards as positive and backwards as negative, then when you add up all the effects, you may end up with some net displacement that is modelled in the mathematics of positive and negative numbers. You're going to see this to great effect towards the end of this course when we do integral calculus. And they're areas under curves, like areas of rectangles, but areas more generally under curves have physical interpretations, and it's important to be able to assign a positive or a negative direction or orientation. This area can be positive or negative. And the rules are that AB is positive, and that's expressed by saying AB is greater than 0, precisely when A and B are both positive or both negative. Okay, the product AB is positive precisely when both the factors have the same sign. They're either both positive or both negative. On the other hand, the product AB is negative precisely if A is positive and B is negative, or A is negative and B is positive. In other words, if the two factors A and B have different sign. Okay, for example, 2 times 3 is 6. 2 times minus 3, 2 lots of minus 3 is minus 6, and that's of course the same as 3 lots of minus 2, and that's the same as minus 2 times 3. Okay. If you introduce another minus, say you take minus 2 lots of minus 3, you don't get minus 6, you get plus 6. The product of two negative numbers is a positive number. If we revisit an example from the previous video, we saw in 2 steps that x is equal to 1 or x is equal to 2. Okay, so the expression x minus 1 times x minus 2 is equal to 0 precisely when x equals 1 or x equals 2. But what happens if we vary x if we change x, it's not 1 or 2? Okay, so if it's not 0, if the expression is not 0, then it will either be positive or negative. And it's very important in calculus to know when certain mathematical expressions become positive or negative. It's related to slopes of curves. Once we introduce calculus, you'll see lots of applications of knowing when an expression is positive or negative. The situation where an expression is positive or negative can be expressed very concisely using something called a sign diagram. And I'll explain it using examples, and you'll catch on very quickly. I draw what looks like a table. I have x on top, and I have the expression that we're investigating below. And there's a line in the middle which is meant to represent the real number line, in as much as that it captures the important points where the expression becomes 0. So in this example, the expression is 0 when x is 1 or 2. So I label those points on the x side as 1 and 2. On the expression side, I put the expression evaluates to 0. If we consider x which are bigger than 2, to the right of 2 on the number line, then both the factors x minus 1 and x minus 2 are positive, and a product of positive numbers is positive. Now if we consider x between 1 and 2, then x minus 1 is positive, but x minus 2 is negative. A product of a positive and a negative number is negative. So on the sign diagram I put a minus sign between 1 and 2. Now if x is to the left of 1, then both x minus 1 and x minus 2 are negative. And remember, a product of two negative numbers is positive. And that completes the sign diagram. It gives you complete information about the sign of the expression as x varies over the real line. Okay, let's do a slightly more elaborate example. Just gradually increase the complexity. Okay, let's find the sign diagram for the expression x plus 1 times x minus 3. And the technique is you first of all work out where the expression is equal to 0. And it's very similar to the previous example. Where you've got a factorization of 0, that implies that at least one of the factors is equal to 0. And you quickly deduce that x is either minus 1 or 3. So now we build our sign diagram where the critical points where the expression is 0 is x equals minus 1 and x equals 3. So I draw points that correspond to minus 1 and 3, and the expression evaluates to 0. And then I just think about the sign of the expression as I move about the real line, backwards and forwards, past 3, between minus 1 and 3, and beyond minus 1. So let's do that. So if x is bigger than 3, then both x plus 1 and x minus 3 are positive. So the product is positive. Okay. If x is between minus 1 and 3, x plus 1 is positive, but x minus 3 is negative, so the product is negative. And finally, if x is less than minus 1, then both factors are negative. A product of two negative numbers is positive. Okay, and that's the complete sign diagram. Notice it's exactly the same as the previous sign diagram, except that the numbers, the critical points where the expression is 0 are minus 1 and 3. If you look at the notes that accompany this video, you'll see some more variations and an increase in complexity in the types of problems. Okay, now once you've got a sign diagram, you can ask yourself which real numbers satisfy a certain criterion, like being positive or negative, or non-negative, which means positive or 0, or non-positive, which means negative or 0. And there's lots of other criteria. And we capture this idea of a collection of numbers satisfying a criterion using the notion of a solution set.